All right. I'll need a note taker for today. Anyone volunteering? No,
Take
no
notes.
one. No one up at once. Cool. I'll put the notes in the chat here for everyone. All right, so I think we'll go ahead and kick this off then. This is Kubernetes SIG On-Prem meeting on May 24th. And we'll start with a demo. I think we'll start with you, Dalton. Tectonic on bare metal?
Sure. I think that'll take about half an hour or so. Is that all right? Does that leave us
hold on a second.
enough time for the other person?
Is it potential to condense that a little bit? We do have some additional agenda items. I don't know if we're going to have.
Okay. We can make it shorter too.
Is Greg actually here? I think Greg wasn't able to present today, so it's you and then some additional follow-up items, but we can only have a...
Okay, I'll do a check-in after a few minutes. I'll see how it goes.
Cool, so we have a 50-minute time slot. So 20 minutes, 10, 20 minutes would be a good shoot for this.
Yeah, I'll slim this down a little bit then. Let me share my screen. Can you guys see my screen?
Yes.
All right. So I actually just sort of wanted to start by introducing Matchbox. I think some of you have already used it before, but it's an open source CoreOS project, which is a separate piece from Tectonic. So I kind of want to draw the distinction between the two. Matchbox is sort of an open source piece of infrastructure provisioning, which is really just a fancy way of saying it's a small service which runs on premise, and it's just a Go app. You can run it as a container. You can run it on a Kubernetes cluster. You can run it directly on a Fedora host, wherever, any host you want really. And it is sort of a small service which sits and listens for machines that are PXE booting. So the way that you hook this up is you can keep your existing DHCP, TFTP network set up however you like, and then just delegate certain machines to Matchbox. And then once those machines PXE boot from Matchbox, you can use the Matchbox API to talk to them or to write configurations for them. In the newest release, we actually added Terraform support. So if you are a person who likes to use Terraform, go for it. You can write configs like that and it blasts them over to Matchbox, or you can just write configs directly, which sort of define how a cluster should be brought up. I guess, so the project lives under CoreOS Matchbox. It's completely open source. This is just a project we do, separate from Tectonic, which depends on this. There are a bunch of cluster examples that I'll point you to. The most interesting one for you guys is the Kubernetes ones, but it's more of a general purpose setup tool for setting up CoreOS clusters or container Linux clusters. If we hop into examples, you can see there are simple examples which will just install CoreOS to the disk, like you would a normal PXE boot, or other ones which actually boot as fully fledged clusters like etcd clusters or Kubernetes clusters. And there are both Terraform examples and manual, non-Terraform examples. And I'm going to hop through one of the Terraform ones today to just set up a Kubernetes cluster locally. We won't have time to dig into the different types of objects being used, but I just wanted to show the demo that's Kubernetes specific, I guess. So this is actually just a checkout of the project. And one of the examples is, this is probably way too small, isn't it? Can you guys see that?
Looks good to me.
Yeah.
Yeah.
So in Matchbox, under examples Terraform, there's one of these examples is bootcube install. And I guess it's unfortunate if you're not familiar with Terraform. This is the example that I've chosen to show, but it's just real briefly. It's sort of a language that lets you describe the types of things you want, and it's really customizable. In this case, there's just a small module that we've written in the example that describes what a Kubernetes cluster looks like. And this is just an example of what you could do. It's, like I said, a general purpose sort of CoreOS provisioning tool. So in this case, if I take a look at the variables being passed in. I'm passing an endpoint for where the Matchbox server lives, which in this case is a local Rocket container. The version of CoreOS to install, a list of all the controllers, a list of all the MAC addresses, a list of all the workers and their MAC address so that we can uniquely identify as a machine Pixie boots, it reports what its MAC address is, and then it's given the correct profiles to become what it's supposed to become in its fully fledged form. And a couple of other details for generating assets. A lot of these details we won't really have time to look into, but I want to show just sort of the way that one uses it. You can run Terraform plan to plan out all the assets you want to create, or if you're not a Terraform user, you can create these assets in the config directory yourself. And apply goes ahead and writes all of those assets into the Matchbox server, which in this case is running locally. And I'm using the local development setup. So there's actually a little set of scripts which will launch some QEMU KVM VMs on the same bridge that I have a little Pixie network set up in. And then while this runs, I'll talk more about it. I just want to get it kicked off since we only have a few minutes. So I have, just to show that that's happening, I have launched this QEMU KVM instance and it is Pixie booting right now. I don't think I can make this bigger. It is Pixie booting into, it's given the CoreOS VM Linus and the CPIO. That's actually Pixie booting. I would show this in one of my spare colos, but they're being borrowed by other people at the moment. So local setup it is, and we'll kind of just wait on this. But I'll talk about it. What should I talk about here? I also really hope this isn't too intense for the screen recording and installing 3 copies of CoreOS Linux and downloading 3 copies of Hypercube might be a bit intense for my network connection.
If you'll take a quick question, just curious, how much resource do you need if I want to go off and do this myself? How big are the VMs, or what do I need to put together?
So like I said, this is the local VM setup, which is just for development. These VMs that I've launched are 1 gig of RAM and a 10 gig disk, which is enough for like spinning up a cluster, seeing that it works, and then throwing it away. Obviously not for like real operation. I'm not really the right person to tell you, like, a lot of people ask questions about like what type of disk, what type of resources their hardware should have. And I'm definitely not the right person.
Yeah, I just wanted to know, can I do it on my a laptop with 16 gig of RAM, or do I need to go cloud?
That's what I have personally for this local setup. And my other cluster, one of my regular bare metal clusters has nodes with 16 gigs of RAM, and there's another one that has 100 gigs of RAM for every node. It varies widely. But on your laptop, I just have 16 gigs of RAM, so that works perfectly fine, I think. The main hurdle is that this is down. So I guess I'll describe what's happening. This just Pixie booted because all the VMs live on a network where they have a working Pixie environment. So that's one of the requirements, is you have some Pixie network set up. A lot of data centers, actually every data center already has this, but that's the trickiest part to set up. It's like a one-time setup sort of thing on-premise. This is the on-premise SIG, so you guys probably already know that. That live boots into a CoreOS instance, which on the very first boot, it's just told to launch a very minimal profile. That profile just pulls all of its configs, and then it writes CoreOS to disk. So in this case, it's actually fetching a cached copy of CoreOS. Just, you can pick in the Terraform definition. Actually, there's a bug about this, but you should be able to pick whether you want the cached copy or you want to pull from the public image. In this case, I'm pulling from the cached image, so that it will write CoreOS to disk, and it'll reboot itself. And once it reboots, it will be, okay, you can see it rebooting itself right now. You can see it enters grub. This is happening on all the machines in parallel. And this node 1 will become a controller, and nodes 2 and 3 will become workers. This is just a specific configuration detail that you saw up here. That failure is normal. The way that I've written it, it is normal. Var. So you can see that I listed node 1 as a controller, and I listed node 2 and 3 as a worker, but you can actually add all 3 of them as controllers or sort of move things around however you like.
I have another question, actually. Does Matchbox do things like power management and such for bare metal machines?
It does not. That is probably the next major feature that's coming. It is purely serving out configs passively. And it's sort of a proxy layer that, supports config objects and matching groups of machines and listening for Terraform and has an API and listens for Terraform connections, and then converts that to just speaking to machines that are pixie booting. And the way that I've written this particular example, which you don't have to do, is it's using the Terraform. Terraform has this feature where it can SSH to a node and do in this case, it's copying a bundle of files, which is part of how we do the self-hosted Kubernetes bootstrapping. That's not every cluster that you provision will need this. Like I said, it's a general purpose provisioning. You could set up a Mesos cluster. You could set up an OpenStack cluster with this. It's sort of whatever you need. In this case, this flavor of Kubernetes requires copying over some assets to the controller as a one-time setup thing. Let's look at what's happening. So if I go on the controller, the kubelet is downloading. You can see my Comcast download speeds creeping along. So we're waiting for the kubelet to download, which is going to slow down bootstrapping a bit. And all that the Terraform bootstrapping has done is set up, has added this kube config, and it has added the kube config you see right here. All these other files are auto-generated, and it has added off to bootkube. I don't know if you guys are familiar with bootkube. Bootkube is a separate project which sets up self-hosted Kubernetes clusters. And by self-hosted, it just means like the control plane runs in pods instead of as binaries on the host. This is just a style of deployment that is popular. And it depends on this one-time bootstrapping because obviously you have to have a thing that brings up those pods initially, one time, like I said.
How does bootkube differ than things like kubeatom?
So bootkube predates kubeatom. It specifically was the first to explore this idea of producing self-hosted clusters. Kubeatom is more of a, kubeatom notably does not yet set up self-hosted clusters. It's on their agenda to have that be an option. So this will just wait until, this is unfortunately going to wait until the hyperkube can download. But you'll see this bootstrap in a moment. What else can we look at? So differences from kubeatom. It's a little difficult because I don't know of anyone at my company who uses kubeatom, but I think it's pretty popular out in like other places, just for ease of setup, maybe.
Well, it seems to be what the current documentation for deploying on bare metal leads you into, certainly on 1.6.
Yeah, probably.
And when you say self-hosted, what does that mean? That the master runs on the cluster nodes itself? Is that what you mean by self-hosted?
That's right. So if we take a look at Docker PS right this moment, what's happening is there are 3 different pods that just got started. There's a controller manager, there's an API server, and there's a scheduler. These are the bootstrapping pods. So kubelet has this ability to listen, to check a particular directory and find static manifests. So the bootkube is just doing the logic of putting in the correct bootstrap manifest, and this tiny set of 3 pods is enough to be a temporary control plane, and it's still downloading images from here. But once that happens, we have a tiny little control plane on our single node controller. This is sort of equivalent to like CPUs booting into like like 8-bit mode, getting into 16-bit mode, and like moving up to become more complex. This is a temporary bootstrap controller, which then allows BootKube to make API calls using kubectl, or using the Kubernetes API in this case, to launch an actual controller manager, an actual API server, and an actual scheduler, which are permanent, and will be spread across all controllers if I were to have multiple controllers. And then once that control plane is stabilized, it will kill off this bootstrapping one, because this is a one-time bootstrapping, and you suddenly have all these pods across your controllers, which constitute a full control plane. And some of the reasons why that's a popular style is that it lets you do rolling updates of control plane components. And it's kind of a scary idea at first, and it was definitely flaky and difficult like a year ago when it was first being developed, but these days it's much more reliable, and it's actually all of Tectonic uses self-hosted clusters now. Let's see okay, so this is currently bootstrapping. So some of the advancements that have come from self-hosted Kubernetes, that particular style, is one, the ability to roll things and manage things using the same Kubernetes control plane tools you're already familiar with. The next is Flannel moved from being a thing you had to configure on all the hosts yourself, which meant it was a provisioning level detail of how you set up the machines, to now Flannel is just run as a pod, actually. Once etcd3 is used, so Kubernetes 1.6, we run Flannel as a pod. And the coolest feature, which is still experimental, is etcd itself runs as a pod. That's like a level of bootstrapping wizardry that I'm not actually completely familiar with. But it is actually supported in my examples here. You can enable experimental self-hosted etcd, and what that'll do is during bootstrapping, it will also schedule an etcd pod. And there's a similar pivot from that bootstrapping pod into a real etcd cluster, which spans all the controllers. But that allows you to like add etcds or remove etcds using the kubectl commands and using Kubernetes primitives. Because kind of the idea is, if these tools are so great for regular applications, it would be fantastic to use them to manage all the important components in the cluster too.
Is this bootstrap technique locked into Flannel? Like, suppose I wanted to use Weave instead. Is that possible or not?
So BootKube is it's a tool for producing a self-hosted cluster. It's not the only way to do a self-hosted cluster. So BootKube does always use Flannel right now, not configurable, to my knowledge. That said, it is using just manifest files in the repo. So if you were to swap out some of those manifest files, you might be able to get to work.
We're actually doing that. We're using Weave and BootKube. Works great.
Perfect. Yeah. They recently switched away from having a bunch of things compiled into just being static manifests, which I think makes it much more customizable like that. Although I don't think do you know if they officially support that, or that's just sort of a customization you've done?
I don't think it's officially supported. We just talked to Aaron Levy about it and just replaced the manifests, and it works.
Cool. That's awesome.
The render step doesn't support using Weave. You have to sort of render and then swap out manifests from what was rendered before you start.
So you'll notice whenever you use BootKube, you'll end up with like a little assets folder that it generates to talk about what these static assets that it uses. And this is actually maybe interesting to look at. I see we're already at 20 minutes, so I'll kind of just maybe 1 or 2 more minutes here. You see it generates a kube config. There's some bootstrapping manifests. Those are the initial 3 you saw. This is the experimental etcd stuff, which I didn't enable. This is the stable control plane, which is currently running, and some TLS assets. I can go ahead and use that kube config to talk to my local cluster, all name spaces, just to prove that there is a cluster here. On that second node, we're still waiting on Flannel to start, but we have a cluster, and it's running on machines which you watched Pixie boot, so it is designed to be as similar as possible to bare metal. And I guess we won't talk about Tectonic, except to say that Tectonic is based on this. It's sort of the enterprise version. It requires a license and it includes some user management features, has a GUI. You can sort of click through and input this same information you saw I put into Terraform just in a graphical interface. And at the end of that process, you'll end up with a nice console, which actually supports like multi-user login and LDAP kind of things. I used to be a developer on Tectonic, but now I just focus on open source things. So I give that a passing mention. This is what Tectonic would look like. So the demo I've showed is just a vanilla Kubernetes cluster, and I'm pivoting to show this separate Tectonic cluster, which is very, very similar, also self-hosted. Just the way that you input information is a little bit different. It still uses Matchbox behind the scenes to bring up on-premise clusters, and then it has these features like that enterprises need, like a nice console or multi-user or LDAP, stuff like that. Or it aims to support rolling upgrades. So you can see how up to date each of your container Linux nodes are and how up to date the Tectonic cluster is. Check for updates. I'm not sure if this actually works. It does work. Whew. Yeah, that's kind of all I've got. I don't want to take too much time from someone else, so I'll stop here.
Okay, cool, great. Does anyone have any questions?
Actually, I'm trying to free my screen and I don't seem to be able to.
I might be able to rest your screen.
Yeah, somebody else can probably request. Awesome.
Okay, I think that may have done it. Great, thank you. As a follow-up, where can people, if they're interested in learning more, where people can follow up with you or with the projects you mentioned?
The project is github.com/chorus/matchbox. There are a ton of examples there to check out. And then Tectonic, I think you can find that. If you're interested in that product, tectonic.com, you can sign up for a license, and it's free up to 10 nodes for people who want to try it. So there's the open source bit, and there's the, if you're interested in the enterprise route, there's a free tier.
Cool, great, thank you. Looking at the next item on the agenda, I'm not sure if they're there. They may be presenting next week, but is Greg or anyone from RackN to show Kate's with Linux Kit? I don't think so. I think they may be participating next week then. Okay. So the next item on the agenda then is documentation work follow-up. Charles, did you have anything to add here?
Yeah, actually, I submitted a contact request to their mailing list and got some detailed feedback. The highlights that I was looking for was basically checking out their process and looking for what we can and can't do. So one of the big questions that we had that came out of the last on-prem meeting was what the process would be around deprecating docs. And there was a large disclaimer that came with that we should not be deprecating anything as far as a wholesale deletion. We need to follow a deprecation process of noting in the document header, right, putting a banner on the top that this is now outdated information, leave a link to what the end user should be looking at, and we leave that in place for about up to 3 months is what they outlined. The other bits were pretty straightforward. They've got a contributor guideline document that's linked as well, and the big thing is they're saying that it doesn't really matter how we want to contribute these as far as like small edits, like single commits per topic, or if we wanted to do a large edit that spans multiple pages, just make sure that they're organized logically and that it's easier for them to review. So if you're going to be doing wide sweeping changes, say that we introduce a new controller that deprecates some features in the Kube controller manager, which is happening with 1.7 with the cloud controller, that's something that they would prefer be done as a topic-based pull request. Everything else, though, is outlined in this email from Devin Donnelly, and I'll make sure that this makes it into the meeting minutes.
Okay. My understanding was the documentation team isn't necessarily super interested in managing the deployment section of the docs, where it's a lower priority for them, where they're more focused on user-facing documentation like how to use and abuse Kubernetes clusters, terminology, and things once you have a cluster running, but that the setup section for them was a lot lower priority. So I chatted with them a couple weeks ago, and they seemed pretty open to the idea that we could help as a SIG kind of shape the Kubernetes on bare metal experience, which of all of the setup documentation, of all the things that exist today, is probably one of the harder, more treacherous areas of Kubernetes setup and deployment.
The interesting thing is I just went through this because I did a public demo at a tech conference just a week ago. And I did it on, quote, bare metal. It was actually VMs, but I followed the 1.6 docs. And having just watched this CoreOS Tectonic demo, I can tell you that what's in the official docs sort of worked, but it results in quite a different cluster from what we just saw in the demo. And docs that would cover every possible permutation are really going to be difficult, and maintaining them will be difficult. Even that the one that's in there now is based on kubeatom, and it does have some faults that lead you to Stack Overflow and the issues database to actually get the thing to work. And I guess my summary is it's potentially a big undertaking, and it probably only applies to one distribution, if you will, which I guess you would be, I don't know, call it the mainstream or whatever. But of course, Kubernetes now, I think they said at KubeCon Berlin that there's 36 distros out there. So it probably doesn't apply to 35 of them if we were to do it.
Which, Steve, do you have a link to the docs that you used for?
Well, I just used the docs on the main GitHub repo for Kubernetes. And so I'd contend that whatever it was the official. I don't have it at my fingertips, but that's how I got there. There is a section with tabs on the left, as I recollect, and it has the major public clouds being AWS and GCE, and then there was one that was just labeled bare metal. So if you go down there, it pretends that the only option is kubeatom. It doesn't mention anything else. I think it did say that one of these, what was the single node one? I'm blanking on the name, but I think it had a note there saying that that's been deprecated. It did note that the old kube was deprecated. So that's how I got where I got. And like I say, I did manage to get it to work. There are some flaws in it, and it's mainly because of 1.6 bugs. There's a bug with kubeatom on putting in the container networking interface. So basically, whether you use flannel, weave, whatever, they're all somewhat broken, and you've got to go through some hand tweak process. But ultimately, I got it to work.
Yeah, so the reason I bring it up is because one of the things that kind of grinds me a lot is from a user perspective, like setting up a Kubernetes cluster there are lots of distributions that do it, and it becomes this matrix, and the docs team definitely tried to kind of encapsulate this as, here is a list of all of the solutions and the operating systems and then the platforms that they run against. That's kind of a table effect, and it's quite large and kind of overwhelming to look through. So if I were to, from my perspective, I jumped through these links just now to kind of see if I could figure out where you ended up in the docs. And I ended up in custom solutions and then on-premise VMs. And then here there's just a whole host. And then finally you're left with bare metal. And then here is a whole other host of options. And so I'd like to, we're never going to be able to say, here's the one solution to do bare metal, because it's going to change if you want to use a different operating system underlying. There'll be some options. If you want to use CoreOS and container Linux, if you want to use Ubuntu, if you want to use CentOS or Fedora, all of those things kind of change the experience. But I'd like to make it so that one of my goals is from a setting up Kubernetes cluster, which to me is more important than using it. It's where I spend most of my days and my times. Is that when it comes to bare metal, it's just a very simple page that says you're either going to know you either know the infrastructure you want or the platform you want to use. So if you pick bare metal, here are the list of platforms you can just jump into. There's Container Linux, there's CentOS, Fedora, Ubuntu, and Debian. And then each of those kind of has a curated, here's probably the best way to get started, and here's a list of alternatives in the bottom.
Yeah. So I just posted, while I was doing this, just so in case I had to do this demo again, I could get back to it. I wrote up personal notes in a gist on GitHub, and I just put that in the chat. When I wrote this, I wasn't intending this to be for public consumption. In other words, this is all I can attest to is this worked for me. But for whatever it's worth, I did write it up in a gist, and I think maybe that does have some references to what I did. And so, after reading that to refresh my memory, there are even some issues with regard to what Docker runtime version you had to use to get it to work and things like that I don't think were covered in the docs.
So that's my greatest fear. I think one of the things I'd like to push this SIG to kind of help shape. All of us here have either some experience managing on-premise, on-metal solutions, or are interested in consuming them. If the docs team is super focused on people,
in my case, by the way, I'm in neither. So I work for Dell, and I'm interested in making it easy for people to deploy on-prem Kubernetes, so they buy Dell hardware to do it. So
absolutely,
I'm a different perspective, but whatever.
But still, the same thing. Your end goal, I think most people's here is the end result is on-premise Kubernetes is a great experience, just as you would expect a couple of commands to launch in a cloud, or consuming GKE as an endpoint, or Azure's Container Linux, container service. So one of the things I'd like to push the SIG to do, and it seems like the docs team's very open to doing, is to kind of help really shape the user experience for bare metal installs of Kubernetes, and making that a very nice guided experience. Here are your options. You pick one and you get a really concise format, and every doc follows the same format. So the experience is really consistent and nice. And then the other half,
I totally agree, but I guess my point is, I don't think this is like a one-time effort. This is going to be like bringing home a pet that you have to feed, take to the vet. Basically, there'll be vet trips every time a new Kubernetes release comes out. I mean, some of the things that's in the current one, like if you go install the very latest Docker, it's going to be broke, and you've got to lock it into a specific version or just an update, on CoreOS or Red Hat. Has the potential for blowing you out of the water. There's a lot of potential gotchas, and it almost strikes me as a real job for a portion of a full-time tech writer, if not a full-time tech writer. So I'm willing to volunteer to work on some of this, but some of this almost is going to call for a staffed position funded by somebody or something.
So I agree, but I don't think I think it's untenable to think that a ragtag bunch of people in a SIG can really make this kind of conceited effort for all platforms to be up to date. What I'd like to effectively push for instead is, let's help define the format for consuming a great experience for installing on-premise, the kind of stuff, the questions that are commonly asked, bare metal provisioners, how do I do power management, how does the solution integrate with existing on-premise stuff? Does it plug to VMware? Is there an endpoint for it to go into whatever else bare metal provisioners there are? And then how do I then go through the installation steps and then really push the communities, the people that are building these products? I know from my perspective, working at Canonical, we'd be very interested in making sure our bare metal installing Kubernetes on Ubuntu docs are super fresh. I'm sure CoreOS's Container Linux experience want to make sure it's super fresh. And then if we can get a couple to kind of say, here's the format we think is best and here's how it should look, I'm sure that others from other communities that aren't here, so I don't want to speak for them, although I kind of just spoke for you, Dalton, sorry.
Actually, I'm really interested in that. It's I think in past SIGs I've been a part of where we try to come up with like one recommended strategy, it always ends in just really all sorts of vendors are going to have interests, and I don't want to push anything on people. Something we've tried to do, or that I've tried to do in PRs to docs in the past, is like there were a ton of like community contributions for how to set up CoreOS clusters, which are wonderful, but also sort of fall behind.
Yeah,
So
people can write it they can get motivated to do it one time for themselves, but then are they going to keep showing up release after release to maintain it? And the answer is probably not.
Yeah. So what we've tried to do is consolidate that into, say, pick platform, bare metal, and then within that CoreOS or canonical, and then within CoreOS we want that to just be like the official curated one. Someone at CoreOS curates that.
I'd like to reach out as a spokesman for Dell, saying that we have no dog in the fight when it comes to distros, meaning what OS.
Yeah.
Ubuntu, a Red Hat variant, or container Linux. I say I want to support them all. And I'd be happy to work with any of you guys. I mean, a lot of your value add on your distro is actually making it a pleasurable, repeatable experience for your customers. And to the extent you'd like to use Dell, I don't propose to do it in a way that's going to break it on HPE hardware. But if, for me to get resources, if we can give an example that just happens to be based on Dell hardware, even though it works on anybody else's too, I'd be very vigorously interested in working with you guys on that to get that.
I don't know of any hardware specific aspects of it though.
Yeah, I don't think there are. It's just that for me to get resources, I have to make a case that, hey, this will, we got a good share of the pie, and if we make it easier for people to consume hardware in general, we're going to come out okay. But I have to at least make the case that, this works with Dell hardware, meaning it's been tested. So to do a walkthrough on bare metal with our stuff, I may be able to bring resources to the table to help out with this.
So that definitely is something. So my interest is, like you said, Dalton, and as well, Steve, like we can't ever do a recommended install. It'll never work that way. It will never work that way by design. And I'm actually really happy about that. Yeah. I'd like to make it a really nice experience. That here is the curated installation documentation that's maintained by either the distro vendor or a prominent set of a SIG or community that's actually maintaining it, actually keeping it fresh. Then eventually being able to say, let's see if we can't get these docs into some kind of CI format so that we can actually just keep saying, hey, next release has broken our docs for our follow through. And then the latter half of the things that I kind of envision, I haven't been to SIG very often, I'm sorry, it's been a very busy month. But I'd also like to start tackling some of like the actual on-prem problems. And the most common ones that come up is, storage and load balancers and other things that are typically SaaS endpoints in a cloud that don't exist, and how we can maybe help shape that experience in Kubernetes for people that have physical F5 load balancers or other things that don't really necessarily that people would expect to have but don't exist just because of the nature of infrastructure and on-prem.
Yeah, that's interesting. There's actually, so from writing the Tectonic bare metal stuff, there's a class of things that get deployed on the cluster that are unique for bare metal. But that's really not specific to Tectonic, and I was thinking of putting them into Matchbox docs to show, like, once you set up the cluster, here are the things that you probably want to add, like here's how to do an ingress controller for bare metal. But those things are also not CoreOS specific either. These are just general purpose.
Just launching pods, basically. We do something very similar for our bare metal stuff as well. We just launch ingress controllers with Nginx, and you can wire them up.
Yeah, like here's how you probably want to deploy. If you're going to deploy this type of thing, here's how you might want to do it on a bare metal cluster.
And so it would be super cool to take a lot of that knowledge from each of the distros and help distill almost like a guide of, like, after you've installed on bare metal, here's a lot of common practices to help get you over the hurdles of how do I manage things that just don't exist at an IaaS level in a cloud.
Yeah. And then going back to, I think, Steve, your comment about hardware stuff, when we're looking into power management stuff, specifically for Matchbox, we're probably being at a higher level than the hardware. We're probably choosing the lowest common denominator of IPMI initially for automated power management. I know that it really is the lowest common denominator across all hardware.
I mean, we've got an open source project going called Rack HD that will manage hardware at IP.
I know.
At the Pixie level, but it also is set up to manage firmware for network switches and things like that. So it's broader than just PCs.
Mm-hmm.
I haven't had time to
that's through EMC,
Matchbox to see whether that might be, something equivalent enough to swap out. I'm just trying to learn your tectonic distribution, actually, and I'd like to get to a place where maybe we could even approach you with a PR to put some of our software-defined storage into it so that customers would have the option to deploy software-defined storage as part of the deployment process.
Maybe. In the past, though, a lot of those things have been add-ons after the fact, as in there's a graphical installer, but it is the minimal thing needed to set up the tectonic cluster. And then I think there is some talk about having like add-ons afterward, and Canonical might be interested in that too, is like a set of, I think everybody is interested in the idea of like a little, whether it's a little marketplace or a Helm charts store or some sort of display of the things you could easily add into a cluster, or it could be in the console, or just sort of vetted. This is how I think in the past we've done like Ceph through Rook, through a little partnership, or
I think Red Hat's OpenShift has a little bit of that bundled into their distro. And then looking outside Kubernetes as a model, if you go look at Mesos, which has the DCOS distro. The DCOS distro actually packages a fair amount of storage components into the install. And they're perhaps a little ahead of Kubernetes in that regard. But
for sure. Yeah, I think product people are super excited about the idea of having a marketplace. Yeah.
Sure. Everyone wants to build a marketplace now.
Exactly.
That's the next cool thing to do.
The way I see it, it's a bundle of manifests. So as long as, however we want to surface that, whether that's a GitHub repo we point people to, whether that's like, I don't know.
So we've got about 5 minutes left of the meeting. I'd like to record potentially some action items, or even if they're pretty shallow. One of the things that I'm planning to bring to the next meeting is kind of a draft of what I would like, what I think a user experience in a doc inside of a bare metal doc from. I've chosen a platform. How could the content be surfaced? Anyone interested in helping to design that with me, let me know. I'm probably going to shop the doc around towards the end of next week in the Slack channel.
I don't know how much time, but I'll make an attempt. Let's say that.
Yeah, CC me on. Sounds interesting.
Cool. And then some other action items is it'd be cool. I think it would be nice to start documenting some of these little tips to get people over the edge, like. Dalton, like you mentioned with the whole ingress controller stuff, like having a document that's like, hey, here's how, if you're on bare metal and you need ingress, here's the manifest you can typically run, or here's an example, a couple manifests. I know like there's the standard controller, there's like traffic, and there's a couple others that do this kind of ingress controller role. It'd be nice to be able to have a similar experience.
I might actually write something on this.
So it would be cool to have something like that as well if you want to try taking a stab at drafting a doc like that. And I think a lot of our early contribution efforts are probably around just kind of wrestling ownership of the bare metal as a platform at the same level of AWS and GCE and stuff.
Yeah, I think that's a good idea. I have a little example of launching 2 ingress controllers, one for ingress, or one for internal, one for external, and how you hook it up. It's actually a much nicer setup if you do have a router or a load balancer that you control sometimes. You can do cool stuff. I'll try to come up with some docs for that, and maybe we can talk about it in a future meeting.
Yeah, I think it would be cool just to kind of keep a heartbeat on this stuff as a kind of a rolling agenda item as we get through, as we kind of get through the rest of the demos and stuff that are aligned.
Yeah. And I can see that being a good one that's well received, because I think we're both using the upstream Nginx ingress controller, and that one's also part of Kubernetes Incubator, so it's an easy one to sell them on.
Absolutely. I think it'd be a good starting position. And then I'm sure other people will say, hey, I've got an ingress controller as well. And then they'll at least have a format for, okay, here's how this should be documented. Here's kind of the flow we expect. Here's the user experience and stuff. And then the whole point is, even if they're bad, they'll at least be consistent. Which I think would be one of my main goals if we start to kind of help the documentation team in this bare metal effort. We have a few minutes left. Does anyone have any other items they wish to bring up? Any lasting comments?
What's the demo next week?
The demo next week will...
2 weeks from now, sorry.
2 weeks from now, yes, will probably be Kubernetes via Linux Kit.
Oh, the one we're supposed to have today. Okay.
Yeah, it looks like they weren't able to make it today. So that'll likely be the one we schedule next time. And we'll figure out with Tomas which one that will be. But that'll likely be the one on there, or potentially Kubermesh or OpenShift.
Awesome.
Cool. So with that, we'll have another meeting in 2 weeks, which puts us, I should probably include in the recording just so people would know.
June 7th.
Yes, that sounds right. June 7th at the same time. I think that concludes. I don't think, unless anyone has any lasting items, we'll go ahead and call this meeting adjourned.
Okay.
All right. Thanks,
Thanks,
everyone.
everyone. Enjoy the rest of your day.
Bye.
Bye.